Hi all. Today we'll be discussing the LeetCode problem of the day 2840. So here you are given two strings, both of same length, and they contain lowercase English letters. So to any of the string, you can apply the following operations any number of times. You have to pick two indices, I and j, such that the difference between the index is even, and then swap the characters. So let's say you pick 3, then you can pick either 5 or you can pick either 7 because difference between 5 and 3 is 2, which is even. Similarly, difference between 7 and 3 is also even. So if you want to pick 3, you can pick either of these indexes and perform a swap. So suppose if you pick these two, then you will swap the position of D and F. So one thing, if you pick 3, then you can't pick 6. So you can't swap between 3 and 6 because the difference is even, difference is odd. So you can only pick two indexes whose difference is even and then perform a swap. So you just have to return true if you can make both the strings equal after any number of swaps. And if it is impossible to make it equal, just return false. Now let's look at the first example. So we have string 1, which is A, B, C, D, B, A. And string 2 is C, A, B, D, A, and B. Let me also write the index. So 0, 1, 2, 3, 4, 5. So to this string 2, let's perform some swaps honoring this condition that two indices difference should be even. Okay, so first we can swap these two positions. Then it will become A, B, and the rest of the string will become will be same. B, C, A. So this is the first swap where we have swapped index 2 and index 4. Now after this, let's do a second swap by swapping index 0 and index 2. So by doing this, the new string will become C, A and C will get swapped, and rest will be same. A, D, B, and then B. So after doing these two swaps, we can see this position is equal to the first string. This position is also equal. D is also equal. B is also equal. And the only two inequalities is this position and this position. And since this is at index 1 and this is at index 5 and the difference between these two positions are even, so we can again swap these two positions. So after doing the final swap, the resultant string will be A, B, C, D, B, A. So this is exactly equal to our string 1. So after doing 3 swaps, we are able to make two strings equal. So we return true. Now let's look at the second example. S1 we have A, B, E. Then S2 B, E, A. Let me also write the indexes 0, 1, 2. So here for this index 0, I can only swap it with index 2 because then only 0 minus 2, 2 minus 0, the difference will be even. So index 0, I can't swap with index 1. So the only possible configuration this string can become is A, E, B. Then again, if we do the swap again, we can swap A and B again and it will reach the original string. So we can see no matter what, how many swaps we do, we can never reach the string S1. So we return false. Now coming to the constraints, both string 1 and string 2 has the same length and the length can be from 1 to 10 per 5. And both the strings will contain only lowercase English letters. Now let's go with the approach. So we have two strings of n length. So let's look at the indices, even index position and odd index position. So let me just write down the index for that. 0, 1, 2, 3, 4, 5, 6, 7, let's say. So now if you want to swap this index 2, you can only pick uh, index 4 or index 6 or index 0 to swap with, because only then the difference between the indices will be even. Similarly, if you let's say if you pick 6, then for this 6 you can only swap it with 4, 2 and 0. So from this what we can see is all the even index positions, we can swap the order in any of the possible way. So similar argument can be made for the odd index position. So if you pick 3, so for this 3 you can only swap this with either 5, either 1 or either 7. So same thing we can say all the characters in the odd positions can be interchanged in any order. So the only thing we need to check is let's say first in the even position, which is 0 to 4 and 6, we just need to figure out what all characters are present. So in the same characters should be present in S2 as well. They can be in a different order, but all the characters present in this even position in S1 should also be present in even position of S2. Then only they can be made equal after doing any number of swaps. Similarly, for odd position as well, uh, whatever characters are present in the string 1 in the odd positions, so the same characters should also be present in the string 2 at the same odd positions. The order can be different, but all the characters should be present. So let's look at this through an example. Then it will be a bit more clear. Yeah. So we have this example. Let me first take the even index, which is 0, 2, 4, and 6. So this is S1 and this is S2. So in S1, all the even index positions are, we have A, we have C, then we have a B, and we again have a C. So A is one present once, C is present twice, B is also B is present 1. So these are all the characters in the even position of string 1. Similarly, we need to look the same thing, even position for the string 2. So for string 2, we have a C. Next, we have a B. Then again, there's a C. So C is present 2 times. Then again, we have an A. So if we compare these two, in string 1, A is present once, C is present twice, B is present 1. And also in string, in the second other string also, we have the same set of characters. So that means you can note that the order is different. In this, the characters are A, C, B, C. But in the second string, the order is C, B, C, A. The order is different, but all the characters are same. And with the argument we made before that all the characters in this even position can be swapped in any order. So after doing some number of swaps, we can make it exactly equal to the string 1 position. So that also we can see. So we can swap this A with this. Should have a C here. And yeah. So if we swap the first index 0 and index 6, then our new string will become A and C. And again, if we swap this index 2 and index 4, then C will come here and B will come here. So we can see we have ACBC, which is same as ACBC of the first string. So after doing some swaps, we can make it exactly equal because both the characters are same. So the same thing, we need to check it for the odd odd position as well. So these are the odd positions. So in string 1, we have B is appearing once, then we have D is appearing once, and A is appearing once. Same thing we need to check for the string 2 as well. So for string 2, these are the odd positions. So A is appearing once, and D is appearing once. Also B is appearing once. So again, if we see A1, D1, B1, which is same as this A is 1, B is 1, also D is 1. So again, the characters are same in the odd positions. So after doing some swap, we can exactly match it with the first string. And to do that, I think in this example, we just need to swap A and B. Then it will become BDA, which is exactly equal to the BDA of the first string. So all we need to do is compare the frequency of the odd position of both the strings, and also we need to compare the frequencies of even position of both the string. If both of these are same, then we return true. Otherwise, we return a false. Now let's quickly code the approach. So first, we'll write a function which will check the even position, the frequency of even position of both the strings. So let me pass string 1, string 2, and I'll pass a 0. So the starting position is 0, and from that we'll just do increment by 2. So 0, 2, 4, 6, 8, and up to so on, up to the end of the string. So let me just create a function. So we'll be passing both the strings, and we'll also pass the starting position. Let's say index. For even case, it will be 0. For odd case, we'll just pass a 1. So when you pass a 1, then 1, 1 plus 2, 3, and then 3 plus 2, 5. All of these increments will be for the odd position. So first, let us look for the even case. So index is 0. Let me quickly create two frequency arrays, which will store frequency of both the strings. So frequency 1. Size will be 26 because we only are storing lowercase letters from A to Z. And similarly, I'll create it for frequency 2. So here index idx is starting from 0, and we need to run the loop while idx is less than s1.length. And inside the while loop, we'll increment index by 2 because we only want to iterate on the even positions. So at each step, we need to store the increase the frequency of s1, the character s1, and also the character of s2. So frequency 1 of s1.char idx plus plus. Similarly, we'll increase the frequency of the s2 in the frequency 2. So once this loop is done, we got the frequency we got the even frequency of both the strings. So we'll just iterate on all the frequency, and if any of the frequency doesn't match, then we'll straight away return a false. So let me just run loop for that. 0, 26. If frequency 1 of I is not equal to frequency 2 of I, then straight away I'll return false. And if all the characters frequency is matching, at the end return true. So this is the case for the even condition. So to do it for the OR condition, all we need to do is just pass a 1. So when you pass a 1 and it gets incremented by 2, so it will check all the odd positions. So at the end, since we need both of the conditions to be true, then only your final answer will be true. So you can just combine them with the AND condition. So you can just say return check of even and check of odd. So since you're using an AND condition, if both of these values return a true, then only your entire function will return a true. Otherwise, you'll return false. We test it. Okay, so this is a character. From that, we need to subtract A to get the relative position. So that means if the character is A, then A minus A will be 0. So A will be stored at index 0. Similarly, if the character is B, then if you do B minus A, this will be stored in index 1. Similarly, if you have the character as Z, so from Z, if you subtract A, this will be stored in index 25. So that's why we have created an array of size 26 to store all the characters from A to Z. me test now. Okay, all good. Let me submit. Yeah, and it works. Finally, let's do time and space complexity analysis. Coming to the time complexity, we are calling this check function 2 times. So if we want to check the complexity of this function, we are starting index at 0 or 1, and we are running it until it reaches the end of the string. So this loop will run at most n times, n by 2, but it will be n in complexity wise. And this loop is running constant. It's only running 26 times, so this is constant. So overall time complexity will be order of n. Coming to the space complexity, we are creating 2 frequency arrays, but the array size is not dependent on the input size. Since this is fixed, the space complexity also will be constant. The space complexity is order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.